Let's learn how to find cube roots of two-digit perfect cubes in your head, and then use the same idea to solve a surprising competition math problem. Suppose someone hands you the cube of a two-digit number, and you want to recover the original number using only the cubes of 1 through 9. Here are those 9 cubes. Look at their last digits. 1, 8, 7, 4, 5, 6, 3, 2, and 9. Every one of them is different. So a cube's last digit tells you exactly what the last digit of its cube root must be. Let's try one. Take n equals 148,877, which we're told is a two-digit number cubed. N ends in 7. Since 3 cubed is 27, the root must end in 3. For the tens digit, drop the last 3 digits, which leaves 148. 148 is between 5 cubed, which is 125, and 6 cubed, which is 216. Using this inequality, we see that the tens digit must be 5. Therefore, the cube root of our original number must be 53. Now for the sequel. The same last digit idea solves a much harder problem. Find the smallest perfect cube whose last 3 digits are 888. This problem is from the 1988 AIME. The smallest such n turns out to be a 3-digit number, which we'll write as 100a plus 10b plus c. Start with the units digit. Which value of c makes c cubed end in 8? Checking the cube of every digit modulo 10, only 2 cubed ends in 8, so c must equal 2. Next, the tens digit. With c equal to 2, we now work modulo 100. Expanding 10b plus 2 all cubed using the binomial theorem and reducing modulo 100, everything collapses to 20b plus 8, which has to be congruent to 88 modulo 100. So 20b is 80 modulo 100, giving b equals 4 or b equals 9. Take the first case, b equals 4. Then n is 100a plus 42, and we can compute 42 cubed is 88 modulo 1000. Cubing using the binomial theorem again and reducing modulo 1000 gives 200a plus 88 is congruent to 888 modulo 1000. Therefore, a equals 4 and n equals 442 in this case. Now the second case, b equals 9. Here, n is 100a plus 92, and we can also compute that 92 cubed is 688 modulo 1000. This time, using similar steps to what we've done before, we land on 200a plus 688 is congruent to 888 modulo 1000. So a equals 1 and n equals 192. We have two candidate solutions, 442 and 192. The smaller one wins. So the smallest cube ending in 888 is 192 cubed. And sure enough, 192 cubed is 7,077,888. Therefore, the answer to the problem is 192.